Now the next problem to be discussed is evaluate integral log of log x plus 1 over log x whole square dx for every x greater than 1. So let I is equal to integral log of log x plus 1 over log x whole square dx. So now we have to get the result by substitution. If you see here, it is a clear-cut picture. If we take log x as t, just see here, let log of x is equal to t. Then we get x is equal to e raised to power t. And if we take the derivative, we get 1 over x dx is equal to dt. That means dx is equal to x dt. That is e raised to power t dt. So we will convert I into the form of t. We get log of t plus 1 over t square into e raised to power t dt. So if we see here, we get log t plus 1 over t square e raised to power t. Now we will convert into another form, that is, if we see, we can solve it by two methods, by simple log t into et or 1 by t square into e raised to power t by taking two integral, or we can convert into the rule by e raised to power x f of x plus f dash x. If you see, derivative of log t is 1 by t and derivative of 1 by t is minus 1 by t square. So we can introduce, to make it easy, that is add 1 by t and subtract 1 by t to get the answer very easily. Otherwise, another method is a integration by part. You can get also answer by using this. So this is a tricky way. So if we see, we get two integral, that is log t plus 1 by t e raised to power t dt minus 1 by t minus 1 by t square e raised to power t dt. So in this form, if you see, this is a function and this is its derivative. So in this case, we get e raised to power t into ft. Also in this case, if we see, this is a function and this is its derivative, that is minus 1 by t square. So it can be written as plus minus 1 by t square. So we also get e raised to power t into function, that is 1 by t. So we get I is equal to e raised to power t into log t minus 1 by t plus c. So here we will substitute the value of t. Our t is log x. So we get e raised to power log x into log of log x minus 1 over log x plus c. So we know that e raised to power log x is x. E and log is cancelled out. We get x into log of log x minus 1 by log x plus c. So by using some trick, you can see we can make the question very easy. So in the end, we get I is equal to x into log of log x minus x over log x plus c is the required answer. So by taking just the trick, by adding and spreading 1 by t, we get the solution very easily. Otherwise, we have to do 2 integral. We convert I into 2 integral and we have to use integration by part and doing so lengthy question. So I already said you have to judge how can we solve the question very easy by using the formulas that are defined in detail in the whole chapter. Now the next problem to be discussed is, that is the fourth one, evaluate integral sin inverse under root x minus cos inverse under root x over sin inverse under root x plus cos inverse under root x dx. So the solution is as sin inverse x plus cos inverse x is equal to pi by 2. Therefore, sin inverse we can replace with theta. Don't be confused. Sin inverse theta plus cos inverse theta is equal to pi by 2. Therefore, sin inverse under root x plus cos inverse under root x is equal to pi by 2. Therefore, we have I is equal to sin inverse under root x minus cos inverse under root x over pi by 2 dx. So from this we also get cos inverse under root x is equal to pi by 2 minus sin inverse x. So we get sin inverse under root x minus pi by 2 minus cos inverse under root x over pi by 2 dx. So we get, here we get sin inverse. We replace cos inverse x by pi by 2 minus sin inverse root x. So here we get 2 over pi sin inverse under root x minus pi by 2 plus sin inverse under root x dx. So we get 2 over pi integral 2 sin inverse under root x minus pi by 2 dx. So we get 4 over pi integral sin inverse under root x dx minus 2, that is 2 by pi into pi by 2 is integral 1 dx. Therefore, I is equal to 4 by pi integral sin inverse under root x minus 1 dx is integral 1 dx. That is 4 over pi integral sin inverse under root x minus x integral of 1 dx is x plus c. Now we have to solve this part. So you can solve it by using sin inverse under root x into 1 dx, or we can solve it by substitution method. So I am solving here by substitution method because that is simple method you can opt to, that is sin inverse under root x into 1, that is integration by part, and sin inverse x is 1 over under root x square minus a square. So you can solve it very easily. So I am opting the another method. We name it as I1 minus x plus c, equation as 1. So I1 is integral sin inverse under root x dx. I am opting this method because you can learn another way to find out the integration of inverse trigonometric function. So let sin inverse under root x is equal to theta or t. So we get under root x is equal to sine theta. That means sine square theta is equal to x. So we have to find the derivative, that is 2 sine theta. Derivative of sine theta is cos theta. D theta is equal to dx. So we'll replace all the values I1. So I1 becomes sine inverse x becomes theta into dx is 2 sine theta cos theta d theta. So we get theta into, this is a formula of sine 2 theta. So we have to use integration by parts. Theta as first function and sine 2 theta as second function. Because theta is a simple value, it may be algebraic pi by 4 something. By the Lie rule, we have algebraic function as first function and trigonometric function as second function. So first function as it is, integration of second function, that is minus cos 2 theta over 2 minus differentiation of theta, that is 1, integration of second function, that is minus cos 2 theta over 2 d theta. So we get I1 is equal to minus theta by 2 cos 2 theta minus minus plus 1 by 2 integral cos 2 theta d theta. So here we get minus theta by 2 cos 2 theta plus half integration of cos 2 theta is sin 2 theta over 2, that is derivative of 2 theta plus c. So we get all the answer in theta form, that is minus theta over 2 cos 2 theta plus 1 over 4 sin 2 theta plus c. But we have theta is equal to sin inverse under root x. So we have to find cos 2 theta and sin 2 theta in the form of sin theta. So we get minus theta over 2 cos 2 theta is also equal to 1 minus 2 sin square theta plus 1 over 4, we can write it as 2 sin theta cos theta plus c. So we convert all the values. Theta is minus sin inverse under root x over 2. 1 minus 2 sin square is x plus 1 by 2 sin theta is under root x and cos theta is 1 minus sin square theta under root plus c. So we get sin inverse under root x minus sin inverse under root x over 2, 1 minus 2x plus 1 by 2 under root x under root 1 minus sin square is x plus c. So if we see, we get the result as minus sin inverse under root x over 2 plus x into sin inverse under root x plus 1 over 2 x is inside, that is x minus x square plus c. So by substituting, the value of integral I1 in number 1, we get I is equal to, that is 4 over pi minus sin inverse under root x over 2 plus x into sin inverse under root x plus half under root x minus x square minus x plus c is the c dash constant of integration, that is c plus We can say this is C1, C plus C1. That is the constant of integration. It is an arbitrary constant. So it does not affect the value of integration. So it was all about a chapter of definite integral where we learn about the typical problem to solve by partial fraction or by substitution or by using the method to form the square, to convert the form into under root x square minus a square or under root a square plus x square and so many forms. So by doing practice, we can be familiar. It will be very easy for us to solve integration problem. In some problem, we use some tricks. So by practice, we will learn how can we use trick in the question to make the question very